So today we're going to talk about one of the biggest reasons why reactions happen the way they do, and that is because of HOMOs and LUMOs. Now you may be asking, what are HOMOs and LUMOs? Well, they are both acronyms that stand for the highest occupied molecular orbital and the lowest unoccupied molecular orbital, respectively. Now we're going to look at HOMOs and LUMOs in the context of a reaction between NH3 and BH3. But before we do this, we first need to look at their shapes and hybridization. Now NH3 is bonded to 3 H's and has a non-bonded electron pair, which makes it trigonal pyramidal and therefore sp3 hybridized. BH3, on the other hand, is also bonded to 3 H's but has no non-bonded electron pair, making it trigonal planar and sp2 hybridized. So next we're going to draw in a molecular orbital energy diagram that shows all of these electrons on each of these molecules. So first we're going to do NH3, and we have a NH sigma bond and an NH sigma star bond, and those are the bonding and anti-bonding bonds of the NH3, and in between we have non-bonded electrons, which are higher in energy than the NH sigma bond but lower in energy than the NH sigma star bond. On BH3 we have a BH sigma bond, a BH sigma star bond, which are the bonding and anti-bonding possibilities, and then we have in between an empty p orbital, and this empty p orbital lies perpendicular to the BH bonds, like so. When we fill in the molecular orbital energy diagram with electrons, we go from the bottom up because I've already written them from lowest energy to highest energy from the bottom to the top. So for NH3 we have 8 electrons, and for BH3 we have 6 electrons. And the empty p orbital is relatively low in energy, while the non-bonded electrons are relatively high in energy. So these non-bonded electrons will go over and attack the empty p orbital. This makes the non-bonded electrons on the NH3 are HOMO, and the empty p orbital on BH3 are LUMO. And now here's what our final product would look like in a reaction between NH3 and BH3, and all because of HOMOs and LUMOs. So I hope you learned something today. Thank you for listening, and have a great day.